Okay, we'll have a look here at bilging of an end compartment. If an end compartment gets bilged, it's not only going to result in our draft changing because we have to regain the lost buoyancy, but we're going to have quite a trim on the vessel. In other words, we're going to have to regain our buoyancy, and it will result in us being trimmed considerably by the head if we're bilged forward. Previous examples looked at a midships compartment, and all that changed was the draft. Once it moves from midships, then you're going to develop a trimming moment, a weight times a distance. So let's have a look at the example given. Our vessel is 80 metres long by 12 by 8 metres, and it's floating at an even keel draft of 4.8. Find the new drafts if it's bilged at a compartment 6 metres long. Well, the sinkage is reasonably straightforward. 6 metres long, the bilge compartment, by 12 by the draft of 4.8. The intact water plane is going to be the 80 minus the 6, as you can see from the sketch above. So it's the 80 minus the 6 times 12, which is 0.389. So when we work out our final drafts, we need to add the 0.389 to the original draft of 4.8. So if you like, that gives us our true mean draft. And now we have to work out what the trim is at that pivot point of the true mean draft. And to do that, we need the trimming lever, if you like. And we need to understand how we get that lever. In this example, our vessel is 80 metres long and the bilge compartment is 6 metres. Before this was bilged, the centre of flotation, the LCF, was bound to be at 40 metres half. Because the vessel's intact, box-shaped vessel intact, LCF, centre of flotation, must be halfway. Once it gets bilged, then the LCF moves back 3 metres in this example, and it would measure 37 metres from the after perpendicular. So LCF2 is going to be at 37 metres from the after perpendicular. Now the trimming lever is measured from LCF2 excuse me, to the centroid of the bilged tank. The tank's length is 6, therefore the centroid must be at 3 metres. So from LCF2 to the centroid of the tank is going to be 40 metres. That's how we get the trimming lever when the water plane area has been bilged. It's from LCF2 to the centroid of the bilge tank. So when we look at the formulas that we've used, the buoyancy lost is going to be the volume of the lost buoyancy multiplied by the density of the water, 354.2 tonnes. The trimming moment will simply be the weight of the buoyancy lost times the distance that we just discussed, 40, which is 14168. And the trim will be the trimming moment over the MCTC, 354.2 centimetres. So now we have to work out what to apportion aft and forward. Because the water plane area has been breached, the centre of flotation has changed. Therefore, we won't be applying half of the trim forward and half aft. Had the water plane area been intact, the centre of flotation would have stayed where it was, right in the middle, the pivot point, therefore we'd have just apportioned half each. Because it's moved back from the after perpendicular to 37 metres, to get the change aft, it will be 37, the new LCF, over the length, times the trim. It comes to 163.8 centimetres. Forward will simply be the after amount less the total we've got, or you could have put 43 over 80 times the full amount and you'd have got that amount there. So we end up with our writing here, our initial draft of 4.8, the sinkage we originally got, we've added in both cases, and the trim, because we're bilged forward, we add the trim forward amount, subtract aft, and get our two final drafts. Obviously we're well down by the head.